C thread and D thread, both is using this one, right? Both is using this one, and array. These two resources is shared in C thread and D thread. And what we want is, C thread is storing some element in the side. This is C thread, and C thread is C thread. This resource is initialized in C thread, okay. And run method is store element. Store element is calling from here. Not this is D thread. It is calling from this one, store it, and it has to store the element, right? And then D thread is also using the same resource, and D thread has to access the element, right? In D thread, access the element from one resource, and the method is this one, right? So this one we tried in the last class, but it was not working at the time, and it was stopped somewhere. So run this and check once. Right, it is giving some exception, fine. So what we tried is, we have taken one flag variable in this, and here no checking, okay, fine, and this flag is true. And if I don't check this at here, at this point, if I don't check, say I'm not using else part also, and this is also not required, then there is no guarantee that first it will store or first it will access, no guarantee, right? And this and check once. Currently it is doing, because okay, it is 0 accessed and 0 stored. First 0 is accessed, then 0 is stored, then 1 is stored, 1 accessed. At some point it can be like this. First it will access, then it will try to store, right? First accessing, then storing. Again 0 is accessed. So in this, if you notice now, 0 is accessed 2 times, and then 1 is stored. What we want is store first, then access, right? That is what we want. So it is like this. The resource we have shared is, first you have one AE, and this is pointing to this object, and then you have one array list or array, this is pointing to this array. It is having 20 elements in 20 empty space first time, or all is getting the 0 first, from 0 to 19, right? 19, like this, and all are having 0 first, and then a thread object we have created, CTH, and in CTH, one CTH is created, CTH reference variable, and this is having two instance member. One instance member is, one is AE, another is the array, and AE is pointing actually to this one, and array is pointing to this one. This we have shared, right? Same way, one D thread we have created, DTH, and DTH is again having some instance variables, and this is also AE and ARR, right? Like this, and this is again pointing to the same object here only, and this is still again pointing to this. So this is resource and this is resource. Both is shared in CTH and DTH. Now what CTH is doing inside the run method, inside CTH run method, you have what you have, and here also you have run method, right? Run method, and in this CH and DTH, CTH is calling, this is CTH, store element with the array, right? Means inside the run method you have AE dot store element, method is called, by providing ARR as an argument, right? And here again it is this one, AE dot access element, by again providing the same array, right? Means on this one thread is calling store element by giving ARR, and again the same object it is calling access element by giving ARR on this object only, right? So what I want is, currently what it is doing, CTH is running and DTH is running, both is running. Which one will run first? No guarantee. And what we want is, first thread only should run first, and it has to store the element. Then only second thread should come, and then only second thread should start accessing. Means at any case, the second thread should not try to access first. right? Only this only should execute first. Then means only the store method has to be called by the first thread. Once this storage is over, then D thread has to start X element. But these two are the threads and starting at the same time. From where we are starting? Starting in the constructor, right? Or if you want to start at this point also, that also you can do. Currently we are not doing here, we are doing that from the constructor start, right? After creating the object, immediately we are starting. If you start later, you can do that. Here in the constructor we are starting it, right? Okay, in the constructor we are starting, and so this statement also I'll delete now. So because currently it is like this, so concurrently which thread will access or which thread will not access, you cannot guarantee that. Now what I will do is, I want a guarantee that first thread only should complete the task first. Then first thread is accessing, C thread is started, and D thread is also started. D thread is also started, right? And this is the class. This is store element called by one thread and access element called by another thread. Both the method, okay? Method 1 and method 2. This is store element method and this method. Both is called by two different threads at the same time, and both the thread started. But what we want is, when first thread comes, say assume this is coming first, then let it execute, no problem, it is fine. But if the second thread comes first in case, and if it starts accessing this, I don't want this thread to enter at this point. This part should be restricted. Even if the second thread is coming first, it should move here. Here only I'll give a block here, and here inside this only it has to move. And when it will go at this part, when these becomes true, when flag is true, at that time only the second thread should enter at this point. Otherwise, second thread should run in the outside. Outside only it has to wait. Right? It should not allow to go inside of this for loop. If it is not going inside of this for loop, then it cannot access the data, right? It cannot run the for loop, it cannot access the data. That is what I want. Then when this will be true, when this flag variable will be true, once the first thread completes the storage, complete storage is over, this complete loop is running, thread is going in sleep state for some time, complete task is over, complete for loop is over, then only the C thread will come into this statement and this thread statement will be executed. And when first thread executes this statement, then flag variable becomes true. Flag variable becomes true. But till that time, what is the flag variable? Flag variable value is by default false. Right. So what I need to do is, I have to at this point I have to write one statement, and I have to check if the flag is false, don't enter at this point. Second thread will come, right? Second thread only will execute this method. And when second thread will come at this point, first second thread will verify that the flag is true or false. If flag is false, don't come at this part. Wait till the flag becomes true. Wait, right? So how will you write this code here? What I can do is, I'll check. I'll write here one while loop, and while loop is infinite times. It has to run infinite times. How long it has to run? It has to run till flag is equal to false. Wait here. Then it will become infinite, right? As long as the float becomes true, till that time this thread runs at this point only, it will not go to the next. And here I'll write one statement to understand that it is busy spin. This is called busy spin of the thread, okay? Until this first thread completes the task, and until it makes this true, even if the second thread comes at the beginning or in middle somewhere, second thread comes, then second thread is going to access this method. But what second thread has to do? Second thread has to run inside this loop till this flag becomes true. That's it. That is what you have to do. And this is called busy spin of the thread. But why you will use this busy spin in this thread, and why not wait and notify? That we'll discuss in wait and notify topic, okay? Why you will use this instead of that, why not wait and notify? You can use wait and notify also. We'll come to that to later. Why not wait and notify? Right. Now you run this and check once. it is definitely first thread will complete all the storage from 0 to 19, and then only this will come to access. But till that time, second thread keeps printing this busy spin, busy spin, busy spin. It will continue to printing this. Now you run that and check. See, this is printing busy spin, busy spin. Means in middle first thread also somewhere, and it is very first, so you cannot actually see here. Wait for some time, then you will see the second thread is accessing also. Right? 0 is accessed, 1 is in middle first thread actually stored some element. Right? Now it is accessing, second thread is accessing, 0 is accessed, 13 is all accessed. Right? But I don't want this many spin, because if you go top also, you will not get this console actually cannot keep all this output here. So you will not see somewhere it is first thread is storing also, you cannot see that, right? So what I will do is I will keep here one try and catch, and this thread also go to sleep state for some time. That's it. Now you run and check. Busy spin for some time. 0 is stored, 1 is stored, and second thread is in busy spin. Right? Second thread is in busy spin. Check. All storage is done. Then busy spin is over and second thread is accessing. So this is called busy spin of threading. On that I have written a blog on Facebook. You can check that. Very, very important. Okay, this is very, very important. Right. So you can do it like this, and this is resource sharing. Right? Resource sharing in multiple threads. Same way. Now, so I hope you understood very clearly what is resource sharing and why you leave resource share. Now in these two threads are performing operation on the same object. Because of that you need to share the resources, right? You need to share the resources. So resource should be shared. But when you are sharing the resource, it has some problems. The problem is, okay, before do that problem, I'll show you how the memory gets memory allocation done when it is multiple threads. So we'll take one more example. Memory, how it allocates in JVM. You have class test 1 in package 11. Every time I am taking a new package, because the class names are same, right? Like this, so it package is different, otherwise it becomes duplicate. And I need a main method also. So this is main method, and I have a class A, some A class, and it has a show method. And inside the show method I am getting the current thread. Th is equal to, okay, it is thread dot current thread, getting the current thread, and run a for loop. Int I is equal to 0, I less than 10, and I plus plus. Sometime it has to execute. And it is printing I value plus 1 tab space plus thread dot get name. That's it, very simple. And as a we will specify the thread name. So what I will do is take another class, a thread, which is extending thread, right? And in that I'll take a constructor also, a thread, so that I can specify a name for this through the constructor. And I'll say here super, and it is name. Name is actually string type name, right? And I'll not start from here. Override the run method overriding, and I need to call this show method. Means I need to take one more resource also, right? The resource should be shared now. So here I'll take one more variable a1, or just a is, and in that I'll take one more argument a, and initialize that. This dot a is a, right? And inside the run method a dot show. That's it. One thread. This is one thread. Now I'll create a is equal to new a. One a object is created. A object. A thread, ATH, new a thread, and the name I'll give ATH. Okay, a thread only, and the resource is A1 is shared. Then from the same only I'll create one more thread, and the name I'll give here, it is say BTH, and this name is also BTH. And then ATH dot start, and bth dot start, right? This two thread created with the same resource, but the thread object I am creating from the same class only. Why? Because the task is same. Two thread is calling the same show method. If you want to take a different thread class, you can take vthread. There also you specify the same show only. You can do it like this also. That is also fine. Now, how the memory will be allocated for this? Currently, if you want to check the output first, just run it and see the output once. Right? So this is BTH0, BTH1, BTH. Why it is like this? Because we are not giving any specific time to delay. So what I will do is give here thread.slip in try and catch. Right, and you say here thread.slip for 500 milliseconds. Now run and check. Right, both the thread is running concurrently, ATH and BTH, and both is having 0 I value. This is actually I value, right? What we are printing here, it is I value. So I value BTH, I value ATH, 0 1 0 1, like this it is, both the thread, right? How it is working. So you know the JVM architecture already. What will happen is JVM architecture is assumed it is like this. Right. So first part consider as a method area where the class will be loaded, right? Then next one I am considering as heap memory, okay? Heap. Next one is heap. The next one is stack memory. This is stack, right? Remaining will come. So when I will write Java and test, output will write somewhere here. When I will write, okay, output I will write here, okay. When I will write Java and test1, press enter. Test1, press enter. JVM has to start, started, and this is the memory inside the JVM, right? Memory is divided into multiple parts, method and all this. Then test1 class has to be loaded first. Test1 is the input, so test1 class is loaded. This is test1. Then inside the test1, what JVM will do? We have discussed in the previous classes. JVM has to create a main thread, right? JVM has to create a main thread. One main thread has been created. Main thread has to place inside the main thread group. So this is one main thread group. Assume this is main thread group, right? And in this program, ATH and BTH both will go to the main thread group only, right? Both will go to the main thread group. And main thread should start. Main thread should start. Now when main thread will start, what is the task of the main thread? Call the main method. How it will call? Inside the run, it has